Hey, ladies and gentlemen, and welcome to Unit 7, Notes 5.1. Okay, so today we're going to start by talking about mutually exclusive events. So let's take a look at what that means. Okay, so first of all, what do we do when the probability says or? Okay, so the probability is going to say or. Last week we talked about when the probability says and. Well, this week it's going to say or. And whenever it says or, you need to add the probabilities. Okay, so if it says or, you need to add the probabilities. So this week we're going to be doing a lot of adding of fractions. So let's do a little review. Remember when you're adding fractions that you need to add the numerators and keep the denominators the same. You can only add fractions if the denominators are the same. And we'll take a look at that here in a second. So let's just start off with some basic OR probabilities, okay? So let's take a look at that first one on your note sheet. It says a bag contains 8 red marbles, 12 blue marbles, 9 yellow marbles, and 11 green marbles. A marble is drawn at random. Find the probability that it is blue or green. So again, we're really kind of focusing in on the fact that it says or right there. Okay, so first let's figure out how many marbles we have. We have 8 plus 12 plus 9 plus 11. That gives us a total of 40 marbles. So now I'm going to calculate the probability of each of those separately. First, I'm going to look at the probability that it's blue. Second, I'm going to look at the probability that it is green. So the probability that it's blue, well, there's 12 blue marbles, so the probability that it's blue is 12 over 40. And I'm not going to reduce that fraction quite yet. I want to keep it the same so that I can add those two fractions together with the same denominator. Now let's find the probability that it's green. Well, there's 40 total marbles, and I want to find the probability that it's green, and there is 11 marbles that are green. So I have 12 out of 40 and 11 out of 40. So I'm going to go ahead and I'm going to add those two together. 12 plus 11 gives me 23 out of 40. So remember, when you're adding fractions, you need the denominator to be the same. The denominator is on the bottom of the fraction, and then you need to add the numerators. So 12 plus 11 is 23. So you can't reduce that fraction anymore, but if you wanted to write it as a decimal, by dividing it out in your calculator, you get 0.575. Okay? Next, let's take a look at this next one. There are 84 teachers at FHS, 12 math teachers and 14 science teachers. Find the probability that a teacher chosen for the commencement speech is a math or a science teacher. So let's go through and calculate this out. First of all, if there's 84 total teachers, that's going to represent the total of our fraction. Okay, now I want to find first the probability that it's a math teacher. Well, there's 12 math teachers, so 12 is the numerator. Next, the probability that it's a science teacher. Well, there's 14 science teachers. Okay, so now I want to find the probability that's one or the other. Okay, so to do that, I'm just going to add the numerator straight across. So 12 plus 14 is 26 divided by 84. Again, adding the numerator, keeping the denominator the same. Okay, that fraction is going to reduce to 13 over 42, which is the same as 0.31. Okay, next, let's take a look at what mutually exclusive events mean. Okay, last week we talked about independent events. That means I had two things going on. One didn't affect the other. Okay, when we're talking about or, we really have one thing going on, but we're looking for two things at the same time. Okay, so for mutually exclusive events, we are looking for events that do not affect each other. Okay, so most of the time, except for very rare cases, you're a math or a science teacher. You're not both. So we're looking where you can't be two things at once. You can't be a Starburst and a Reese's. You can't be a red chair or a green chair, okay, if you're one color. So we're kind of looking at stuff like that. So for example, here's the example written on here, rolling a 5 and flipping a coin. Okay, we're not going to have the same thing on a dice and a coin. That just doesn't make sense. So that makes them mutually exclusive. So if you need more time to write this down, pause the video and write it down for me. Next, let's find these probabilities. So one teacher must be chosen to supervise the senior class fundraiser. There are 12 math teachers, 9 language arts teachers, 8 social studies teachers, and 10 science teachers. If a teacher is chosen at random, what is the probability that the teacher is either a language arts teacher or a social studies teacher? So first we need to figure out what our total number of teachers is. We have 12 plus 9 plus 8 plus 10. And that's going to give us 39 total teachers. So first thing I'm going to do is calculate the probability that it's a language arts teacher. Okay, and there's 9 language arts teachers, so we can write that. Next, I'm going to add the total. So again, my total is still 39. We're still drawing from 39 because you can't be a language arts teacher and a social studies teacher. So let's find the probability that's a social studies teacher next. Well, there's 8 social studies teachers out of the 39. So now we're going to add those fractions. 9 plus 8 is 17 over 39. That fraction is completely reduced, and you can also write it as 0.436. Next. Oops, forgot I was on this page. Okay, let's take a look at that next problem. So, whoops, I'm having a struggle fast, don't judge. Okay, let's take a look at number 2. There are 4 algebra books, 3 literature books, and 2 biology books on the shelf. If a book is randomly selected, what is the probability of getting a literature book or a algebra book? Okay, so can you be a literature book and an algebra book at the same time? No, you can't. So let's figure out our total number of books. We have 4 algebra books, 3 literature books, and 2 biology books. Okay, so we need to figure out the probability of selecting a literature book or an algebra book. So we have 4 plus 3 plus 2, so there's 9 total books. Okay, and first let's find the probability of getting a literature book. Well, there's 3 literature books, so the probability of getting a literature book is 3 over 9. Again, 9 total. Now I want to find the probability of getting an algebra book. Well, there's 4 algebra books out of 9 total. So we're going to add the top, keep the bottom the same. 7 over 9 gives you 0.778. Okay, next, let's take a look at number 3. Okay, so for number 3, a card is drawn from a standard deck of cards. What's the probability of drawing an ace card, ace, or a face card? So you need to ask yourself, could something be an ace or a face card? And the answer is no. An ace doesn't have a face on it. So it's not an ace card, or it can't be a face card. Okay, so first of all, we know that there's 52 total cards in a deck. Okay, so out of the 52, there's going to be 4 aces. There's going to be the ace of clubs, the ace of diamonds, the ace of spades, and the ace of hearts. So there's 4 of each of those. Next, I want to figure out the probability of that it's going to be a face card. Well, there's jack, there's queens, and there's kings. So there's 3 face cards per each suit. So there's 3 face cards per each suit. So let's write that out. So 3 face cards times 4 suits means there's 12 face cards in a deck. So the probability of getting a face card is 12 out of 52. So let's go ahead and let's add those together. 4 plus 12 is going to give us 16 over 52. So now we can go ahead and we can turn that into a decimal and reduce the fraction. So 16 divided by 52 reduces to 4/13, and that's the same as 0.307. Okay, so that's your probability for getting a card. All right, next, I would like you to pause the video, and I want you to try this should say number 4. Oh, let's have you try, maybe it's not on there, we go. Try number 4 on your own for me, please. Okay, so I'm gonna have you guys go ahead and try number 4. So there it is right there. So talking about those graphing calculators, okay, I want you to calculate the probability that is a graphing calculator or a regular calculator. This would say or, so figure out your total number of calculators. First, calculate the probability of getting a graphing calculator, then calculate the probability of getting a regular calculator. Okay, now let's take a look at number 5. Okay, here is number 5. There are 3 different types of candies in a bowl. There are 6 Reese's, 8 Starbursts, and 10 Dum Dums. What is the probability of getting a Dum Dum or a Reese's? So let's figure out how many we have. We have 6 Reese's, 8 Starbursts, 10 Dum Dums. Okay, that means that we have a total of 24 candies. So a total of 24 candies. And first I want to find the probability of getting a Dum Dum. There's that or. Okay, so I know I'm going to be adding. The probability of getting a Dum Dum is going to be 10 out of 24. Now I want to find the probability of getting a Reese's. Well, I still have 24 Reese's. and that's 6 out of 24. Remember, when we're adding, we don't want to change that denominator so that we can add them together. Then you end up getting 16 divided by 24. That reduces to 2/3, which is the same as 0.67. Okay, so before you guys come and show me your note sheets, I want you to try number 6 on your own. Number 6 says, what is the probability of drawing an ace or a king from a standard deck of cards? So I want you to try number 6 on your own. So you need to do number 4 and number 6 on your own. You need to have those completed before you bring your note sheet up to me. Once you're done, bring it up to me and I'll check it off and give you your homework. Thanks for listening.